Write down the expression for the Maxwell Boltzmann's distribution law and use it to derive the root mean square velocity of molecules. So this is a question given to us over here. So the first thing we need to do as required is write out the law. So that is going to be P of V. That is equal to 4 pi multiplied by m divided by 2 pi kt. That will be raised to the power of 3 divided by 2. This will be multiplied by e raised to the power of e 1/2 multiplied by mv squared, all divided by kt. And this is now multiplied by v squared. Now we already know that a half mv squared, that could be rewritten as a mv squared divided by 2 in it. Now what if we had a kt, that is the common divisor of this whole stuff? That will leave us with this, and this obviously is going to go down, so we should have something like this: mv squared divided by 2 kt. This is what we're going to have. Now I'm going to change this expression here and use this rather. So the equation should be transformed to something like this. Here we're going to have a m divided by 2 pi kt raised to the power of a 3/2. This is e to the negative mv squared. This will be divided by 2 kt. This is multiplied by v squared. So this is basically the probability density, or the Maxwell Boltzmann expression or equation, I would say, for the speeds of molecules of gases, as you might want to have it. This stuff, this actually stands for the probability density of molecular speeds of gas molecules, and this stands for the mass of the gas molecules. K here, that stands for the Boltzmann's constant, and that is actually always given. Now T stands for the absolute temperature, and I think we got a V. So V squared, that is the square of the velocity of the molecules. But we're basically going to use this to make most derivations here. So basically you might not even see this being formed at the end of the transformation anymore. So let us go on. Let us find out how you can get the root mean square velocity from this equation. So the first thing you need to know is that root mean square velocity, which I'm going to represent as a VRMS, this is equal to the square root of the average squared value of the V. That is the velocity of the molecules. So if you want to do this, you want to find out what is this stuff. This is basically the normalized velocity for the molecules of the gas. So what is this going to look like? So I need to represent this above. So this, well, I need to rewrite that. This is equal to the integral of v squared multiplied by pv. And this is basically the velocity. So if we integrate this, this must be with respect to the velocity. So that will be written that way. Now basically we integrated from v equal to 0. That is where the velocity is completely not there until v equal to infinity. So this is what it is. Now this is basically what we need to find out, and from there we're going to plug it back into the equation and try to go on. So I just want to wipe these out for now. Now the next thing we need to do is take this, which we know is the distribution law, and plug it into this function. And so I'm just going to use an infinity here and a 0 here. we're going to have a v squared here, and we need to write out the distribution law. So that is a 4 pi multiplied by m. That will be divided by 2 pi kt raised to the power of a 3/2. And this is multiplied by e raised to the power of a negative mv squared divided by 2 kt in it. Now this will be multiplied with v squared as usual. And this should be multiplied by dv for the fact that we got a dv over there. Now from here you can see that v squared is going to get multiplied with v squared, and that should pretty much give us a v to the 4th. So we're going to have this. Here we had an infinity. This is a 0. And we're basically going to, well, I think I'm just going to take out these brackets. We have a 4 pi multiplied by m divided by 2 pi kt. And this is raised to the power over 3 divided by 2. So this is 3 divided by 2. This will be multiplied by e raised to the power of a negative mv squared divided by 2 kt. And here we're going to have a v to the 4th. This is going to be a dv. So pretty much it. That is what we got over there. Now next off, we need to integrate this. As you can see here, we got a dv. That means v in this case is the notable variable here. So every other thing which does not actually have a v or a v squared or any degree of the velocity of the gas molecules attached to it, that is basically going to be taken as the coefficient. So stuff like this is really going to serve as that. And so basically, as you work this calculus operation on basic functions, you want to take out the constants which serve as a coefficient away from that place. So I'm just going to take this stuff and place it outside here. So this is what we're going to have. This will be v squared, and I'm going to have a 4 pi. This will be multiplied by m. That is going to be divided by 2 pi kt. And we're going to have a 3/2 here. And over here, we're going to have this. So this is e raised to the power of a negative. Well, I think I'm just going to write the v squared. Well, v to the 4th first. And here we're going to have a e to the negative mv squared divided, I think I need to write that better now. So this is going to be divided by kt multiplied by dv. Now, we want to see how you can work this. How can we work this part? Now, we're going to use a method that is called as the Gaussian integrals. So how does that work? If you got integral to infinity and from 0 of x to the 4th e up to the negative a multiplied by x to the 2nd power, and that is with respect to x, so that should be dx. The answer to this integral is gonna be 3 root pi divided by 8 e to the power of the 5/2. This is gonna be the answer. So we want to use this comparing and find out what is going to be the a there. So I'm going to write this here. That is infinity, and here we got a 0. This is going to be v to the 4th, and here we're going to have a e to the negative m divided by 2 kt. So I need to write it out better now. 2 kt multiplied by v squared in it. This will be dv. So by comparison, we can see that this stuff truly looks like this, and we got an x squared. And here also there is actually a v squared, so that works there. We also got an x to the fourth, which we also got a v to the fourth here. There is also a negative from the standard integral. There is also a negative here. So from there, we can see that a is obviously going to be equal to this stuff. This whole stuff, which you see here. This is going to be a. So I need to write it out now. So from here, we agree that a, that is going to be equal to m divided by 2kt. That is what we got for a. Now I need to plug it back into the formula answer. So what is that going to give? Let us look at it. So this is going to be 3 root pi. This will be divided by 8. Now a is equal to m divided by 2kt. And this is raised to the 5 halves. So I need to rewrite that again over 2. This is what we're going to have. So this stuff, this is actually equal to this. So we're going to have the whole thing look like this. So this is going to be 4 pi multiplied by m. This will be divided by 2 pi kt. This is raised to the power of a 3 halves. So I'm going to take these out now. So here we're going to have a, this will be a 3 root pi. This is going to be divided by this stuff, which is a 8 multiplied by m. So I need to make sure stuff is written out well. I'm going to take these out. So this is going to be 2kt. So we got this to be 5 halves. So pretty much it. So we need to combine these stuff and find out what is going to be the total value. So first we're going to start with this. So here we got 3 multiplied by root pi. And here we actually got this. This is actually going to be multiplied by, I think we got 1 divided by 8. And this will be multiplied by m to the 5 halves. And this is going to be divided by this. Divided by 2 multiplied by k multiplied by t all raised to the power of a 5 half. Now how can we do it? From the laws of indices, we know that it is very possible for us to take this power and apply it on every term within that bracket. So this should be 2 to the power of a 5 half. And here we're going to have a k to the power of a 5 half. We also got a t to the power of a 5 half. Now this is what we're going to have. Now from here, if you got a 1 divided by a divided by b, b is going to shoot up. And so we're going to have a b divided by a. This is what is going to be the product. So that is exactly what I'm going to use. So from here, we know that. Okay, so I'm going to take these out for now. So from here, we're going to see that we got 1. That will be multiplied by all these because we have them as the denominator of a denominator. This was the numerator, and this is actually the denominator, which is a fraction on its own. This is a numerator of the denominator, and here we got the denominator of the denominator. So this is basically going to go upward. So that would be 1 multiplied by this as it comes. So instead of the 1 there, I'm just going to write what that is going to be for. So this is 2 to the 5 halves. Here we're going to have a k to the 5 half. This is going to be t to the 5 halves. Well, this will be divided by 8. 8 multiplied by m to the 5 halves. Well, so this is basically what you got. Now remember, this was multiplied by 3 pi, so we need to write it out there. So that is 3 multiplied by root of pi. Now from here, we could take this stuff up, and that is going to take a negative symbol for its power. So we should have something like this. This is going to be 3 multiplied by root pi, and this is going to be multiplied by 2 to the 5 halves. Well, multiplied by k to the 5 halves. This will be multiplied by t to the 5 halves. And here we're going to have this will be 8 to the negative 1. And here we're going to have a m to the negative 5 halves. So this is what we have from here. Now remember, this is multiplied by this stuff. Now I want to split out what this stuff is, or is basically going to look like. So we know, first of all, there is a 4 and a pi there. So this is a 4 multiplied by a pi. And this is going to be multiplied by m raised to the power of a 3 halves. So this is going to be m to the power of a 3 halves. Then we got this. Now we need to take this up. Now if we're going to do that, we need to apply the negative powers. So here we should have a 2 to the power of a negative 3 halves. And here we're going to have a pi to the negative 3 halves also. And here we're going to have a k to the negative 3 halves. Cool. And this is t to the negative 3 halves. Now, we know that this stuff, this was basically multiplied by this. So basically we need to take this and have it multiplied with this. So we're going to combine the like terms. So I'm just going to take these away. Now here we got 3 pi. Now notice this is actually going to be multiplied, so there is no subtraction. So first we're going to have let us start with the numbers. So this is going to be a 3, and this is multiplied by 4. This gives us a 12, and then we got 2 to the power of 5 halves. This is 2 to the power of negative 3 halves, and basically we also got a 8 to the negative 1. So I'm going to attach them. So this is multiplied by 2. This is 2 to the power of 5 halves multiplied by 2 to the power of a negative 3 half. This is multiplied by 8. Okay, so this is 8. Now I know that 8 is 2 to the third power. Well, so this is 2 to the third power. And this stuff was raised to the negative 1. So let us try to work this. What is this going to give? Now for this, we know this is going to give us a 12. And we got this. So this is going to be basically 2 to the power of a 5 half minus 3 halves minus a 3. This is what we're going to have. So we need to work there. This is basically going to give us 2 over 2. So we're going to have that as a 1. So that will be 1 minus a 3. So this is going to be equal to 2 to the power of a 1 minus a 3, which should give us 2 to the negative 2 in it. So this leads us to 12 multiplied by 2 to the negative 2, which is basically, so I need to take these out now. This is going to be equal to 12 divided by 4, because this should give us a 2 to the power of a 2, which is a 4, and that is raised to the power of a negative 1, which means you should divide 1 by 4. That is 1/4. We could actually change this. This gives us a 3. So we're basically going to have a 3 there. So the combination of all the numbers actually gave us a 3. So we need to place it somewhere. So the numbers 3 was actually the answer. So we're done with the numbers. Basically going to take it out. So these are going to go. So these going out. We're taking these out. Going to take this away. Basically. Next up, we're going to work with pi. What is pi going to give? So first we have this, which is going to be pi to the power of a half. This is multiplied by pi to the power of a 1. That is this one. Now we got this, which is pi to the power of a negative 3 halves. So this is going to be pi to the power of a half plus a 1 minus a 3 halves. And this is basically going to give us a 3 half. So we're going to have a 1/2 plus a 1. That gives us a 1.5, which is basically 3 halves. And so you got 3 halves minus 3 halves, giving you a 0. So basically we got a pi to the 0th power, which is going to be a 1. So pi gets reduced to a 1. So we're not going to have no pi's no more. So that is what we got. Next up, we're going to move to m. So we got m to the power of a 3 half, and that is multiplied by m to the power of a negative 5 halves. So we know this is going to be m to the power of a 3 half minus a 5 half. This should give us m to the power of a negative. So this is going to be a negative 2 over 2, which is m to the negative 1 in it. So we're going to have that. I'm going to write it out somewhere. So this is the next value, which was gotten m to the negative 1. So I'm going to take m out. So we got this taken away. Next up, we got to work with k. Now this is going to be k. K is raised to the negative, oh, that is a positive, 5 halves multiplied by k to the negative 3 halves. So this is basically going to give us k to the power of a, this is going to be k to the power of a 1. Because we're going to have this as a 2 over 2, so that will be k to the power of a 1. So here we got k to the power of a 1. So we're done with k. Now we need to go to the last one, which is t. So that is going to be t to the 5 halves multiplied by t to the negative 3 halves, which still gives us t to the power of 1. So here we're going to have a t to the power of 1. So basically we have been able to get all the values or the terms from this part. So we got v squared, that is going to be equal to 1 over m, and this will be multiplied by k. This will be multiplied by t and multiplied by 3. So this is going to be 3kt divided by m. Now we know that VRMS, that was equal to the square root of this stuff in it. We have gotten this now. This is equal to this. So therefore, we're going to have a VRMS that is going to be equal to the square root of a 3kt divided by m. So that is what you're going to have. So basically, that is going to be the root mean square speed or the root mean square velocity. Now, what if we need to express this in other forms? How are we going to do it? Now, you need to know that R is equal to the Avogadro's constant multiplied by K. That is the Boltzmann's constant. Now, from here, we got the Boltzmann's constant in this expression. So if we made that the subject, that is going to be R divided by NA. So I'm going to take these out. Now I'm going to take this and plug it back into that. So we're going to have something like this. So this is going to be 3. And I'm going to take R, which is, well, that is K rather, which is R divided by NA. This will be multiplied by T. This is divided by M. Now we know this stuff is basically going to go down. So we should have a so this is equal to 3RT divided by NA multiplied by M. Now this stuff, NA multiplied by M. Need to write it out somewhere here now. If you got this, Na multiplied by M, this is equal to the molar mass of the gases. So in that case, we can find a new form, that V RMS, that is equal to the square root of a 3RT divided by M to the uppercase. So this is the one formula. This is the other one. Now you also need to hold this at the back, as well as this. So that is basically it for this video.